options that you can use. So the option where is -g, and then you can set which group of function we are interested on. So you will get a table only for these functions, okay? So just to make more in a case, so for example, if you want to understand all the operations that you do when you do allocation of the heap memory, so these are the functions that, for example, in this case, you will trace, okay? You will get this information, okay? Then there are also other options where for these other group of functions. This is the table that you get, okay? So you can understand how many allocation, how many are free, and then so allocated free and so on, so you can understand which are elements if you have in a situation where you are leak, so memory leak, okay? So this kind of options that you can use, there is a full list, and then of course you can do path help to understand, or main page of path build to understand the meaning of these functions, okay? Same for part report, there is another list of functions. This is just to produce the tables. So maybe you are interested to understand the hardware counter, so you can specify this option here or all the others function, okay, a group of function. And this is just to get best from the report on the screen, so you can have a different kind of information, just grouping this information in a better way, basically, from path report. Okay. Anytime if you have a question, just ask me, okay? So now how we can change the behavior of the Cray path, okay? So the interesting point is that, as we showed yesterday, you don't need to change your code, right? So use path build on your executable, you do a new executable, and then you use path report to show the information. So you don't need to change your code. Now, how we can, interact with this new executable? There are environment variables for that. All these environment variables start with path underscore RT underscore, and then there is a given option for given environment variable. So you set this environment variable, and then you change the behavior when you run your instrument code, okay, executable. You run this on the shared file system just for performance, because most of the time, if you run with a given number, let's say 1,000 MPI ranks, you will dump a lot of information, right? So they will write on the disk, and you cannot stay in your home directory. So you need to specify something which is inside here. All the scripts I provided you yesterday for the practicals are making a directory in the file system, in the Lustre file system, Elastic file system. So these are, let's start with this environment variable, where you can set like experiment. This is an easy way to change the behavior of your profiling, basically. So the default is sampling the program counter for time. Okay, this is just for sampling, basically. And you can set, for example, using this variable here, you can set the timing of the sampling. Okay, we saw that in between you do this in the GUI, right? There is if you remember, when you do sampling hotspot analysis, for example, you can set 10 milliseconds, not microseconds. It will be too fast. And this is the same way we do in Cray. You just set environment variables. But then there are other kind of experiments that you can run. For example, in this case, you do sampling when you reach a threshold given hardware counter. Okay? So it depends which kind of experiment you can collect different operations. Okay? And this is the case where you do just call stack information. Okay? It can be the faster one. Okay? So the default one, well, it give you more details for your application and so on, okay? So the two variables are these, where you can have these three values, and then if you want to change sampling time, you can use this and other environment variable. There is another interesting environment variable, was already a discussion yesterday, that you can set is path RT summary equals 0, and with this variable, you will dump all the information. So you will produce very big file where you can see then all the informations or the execution of your application. So you will do tracing over time, basically, okay? Keep in mind that when you do sampling, then you will get an average of your, for example, this function is called 1,000 times. An average is taking, I don't know, 1 second per call, okay, in average. But if you want to do tracing over the time, so you want to send for a given amount, after a couple of seconds, what is the real time, you can set this variable here, and then you can see the trace on apprentice, okay? Then, of course, there is ways, because when you set this variable, you will produce, as I said, a lot of information. And if you're running an MPI with a given number of ranks, so you will produce a lot of information. And this is not linear, okay? The amount of information that you are producing when you are running with different MPI ranks is not linear. This is just to give you an idea how it works. And there are variables that you can use to reduce the amount of information, just because otherwise you will produce terabytes of files, okay? And then you need to analyze this data. And maybe you are not interested to analyze everything. So there is this variable here. You can customize how many files. But then there are other variables that you can use same way, okay? You can use this to control the dimension of the files that you are dumping, okay? So you can see the explanation of these variables here, basically. I don't want to give in details, but these are the things that if you analyze your application, and in a case you are running with several MPI ranks, okay? All right. Other variables that we can use, this is change the threshold for tracing, okay? As I mentioned before, so the amount of time that we need to spend for a given application. So maybe you don't want to do the full trace or your entire application, but just for a given amount of time and so on. Okay, so these are our variables. Another interesting thing is the way to use APIs. So I think it's much better because maybe there is an initialization part in your application, and maybe you are not interested to see what's going on in the initialization part, okay? But you want to understand, for example, I don't know, given file, for example, a loop, you want to just shrink your profiling to given portion of your application. So use APIs. These are the way they use it, okay? So there are, you set the state. So you start in a situation where there is no profiling, so it's pause, okay? And then you start the profiling, and then you can stop. And then you can record over given phases, okay? So I will give you an example in the code. So you can just profile with these two functions. Of course, there is the equivalent for Fortran. You can profile with these two functions just a portion of your code. So for example, this is the case. You start in a situation, your application is off, okay? So you put at the beginning that it's off. Then you have an initialization part I mentioned before, but whatever you can have. And then you start a region, so you start to record, so now it's on. And then you can start in this region here. So then when you do the profiling, you will see step 1, okay? So this is the means that is profiling, okay? Is doing profiling, whatever, tracing or sampling, just in this region, okay? All the functions which are inside here. And this is just taking for step 1, okay? And then there is another region, okay? Then this beginning end, and then there's another region which is with the label step 2, okay? So you will skip the initialization part, and then you will see only the functions which are inside these regions with this given flag, okay? Let's say you have 2 loops inside here. You can call loop 1, loop 2, or let's say loop energy, loop or whatever. I mean, you can give meaningful names, okay? So these are very useful if you have a very large application, but maybe you are interested to optimize just a portion, so you can use these APIs. The other interesting thing that is setting an environment variable, which is not explaining here. Yes, it's setting an environment variable. So when you use module load perf tools, okay, just when you load module tools, perf tools, you will set the Cray compiler will set also this variable here, okay? So in case you don't do profiling, okay, this variable is not, this macro is not set, and of course you can use if-def around this call to skip it, okay? So that you need to change the code when you are using APIs or not using APIs. All right, so this is the case when I mentioned before, when you use this variable and you do the information over the time. So you dump the information over the time. And this is the case when you are producing, as I said before, huge files. So maybe it's better then to consider other options to reduce the amount of files and so on, okay? So here, there's a recommendation to use just a small number of cores. So maybe don't use this option if you want to, 1,000 nodes, basically. That's the suggestion. So question so far? No? Okay. So let's jump in other counters. So yesterday was this description. Basically, what you can imagine, there are specific registers inside the CPU. Okay, they are called PMU registers. Okay, and these registers, there is a given number of registers which are fixed. So people, people said, okay, these are registers. Let's say how many clock cycles and so on. So everybody is interested in this. And then there is a given number of registers. In the standard bit, there are 3 registers. You cannot change. And then there are 8 registers, so in total 11 registers, counters, which are, you can change the value that you want to register, okay? So they are optional, basically, okay? So let's say you are interested in more than 11 events, let's say you want to understand AVX, SSC, scalar, and then memory access, and so on, the application will do what is called a multiplexing. So it will run with a given setting for the registers, for the counters, and then over time it will change and will collect all the events in a single run. It will do multiplexing, and then also what you get is an average of the events over your application, okay? So keep in mind that if you want to collect in one run 1,000 events, it's not possible because just 11 of that can be collected. But there are ways to solve this problem. Multiplexing is one of these problems. In our application, we use the PAPI interface, so we can collect events. And as I said, I will not give in detail how it works, but the point, what is important for us, is there are, okay, here there are path help that you can understand which kind of events we have in the Sandy Bridge. There are groups events can be interesting for you, so you can just set here an environment variable, okay? And you can specify, using this environment variable, which set you are interested on. So you will collect all these events in groups, okay? And then you will dump all the information for this group, okay? Depending how many, then maybe you are not interested, but depending how many counters you have, then it will do multiplexing for you. But at the end, it will dump this information. So there are different groups. This is a list of groups, okay? So this is for caching, for example. Then there are for AVX, SSC, AVX, single precision, double precision. These are different groups of counter, and as I mentioned before, you can just set here. Otherwise, you can set your event list. So you need to understand the name of each event, and you will put the entire list here. As I mentioned before, you can see here what is what are the names of these events, and you can put the entire list there. Then, as I said before, you run again your application. It will dump the information. Remember, path build. Okay, that's it. Then you set the variables, the environment variables. Then you run path report. You run your application, sorry. And then you run path report, and you will get this information. Okay, this is how it works, basically. Okay, and you will get a table where you get this information, and this is the case here, where you have the information. This is for using 0. So this is the case here, just data 1 cache. Okay, and you will see all the informations on the path report. Okay, on the tables. That's the way how it works, okay? This is cache level 1 data cache misses because the group 0 is D1, okay? Then, but maybe you are more interested in other groups, okay? So if you are really expert and you are really interested to see one single event which is not in this group, then maybe you want to specify in the list. But then you need to understand that there are hundreds of these events, okay? Because you can usually do monitoring all these events inside your CPU, basically, okay? All right. After that, so how you can get this information? This is when you set path report equal 0. Then, for example, in this file, you want to be interested to filter over, for example, a given MPI rank. So, for example, in this case, you can set here this condition or this condition, and you will dump the information from path report for specific ranks, okay? Okay? Just to select in the path report the information that you want to have, okay? Instead to see all this information. This is for large tracing, okay? Not one single application, one single core. So now let's move to next step is loop statistics. So how we can understand better what's going on in our loops. So which kind of optimization done by the compiler. There is also here a flag that you can set in the Cray compiler environment, which is profile generation. Okay, it will do tracing of the loops. Okay. So, well, we already saw some of this profiling yesterday. And then you will have a path report table for the loops, specific for the loops, okay? So for tracing, you specify, as I say, when you compile this, okay? And then you need to set the tracing, okay? So for tracing, you remember yesterday we did in the practicals, there is this option, all right, or then you can use APA file. Of course, when you use APA, that means profiling, and since we are setting this variable, APA will dump all the tracing information for the loops, okay? That's obvious. Otherwise, APA is smart enough that to understand if this loop is important, will do tracing, okay, automatically tracing. So if you remember what is APA, okay, the automatic way to tracing. Okay, then of course you can run again path report. So this is at the level path build. Then the path report you will dump the loop report. So it will tell you some information. Some pragmas is using the compiler for the optimization. It will dump the information of the loop. Okay, so it will collect in a different table, table 2. It will collect all information for these loops. and it will tell you all the information, no vector adds vector, and of course there is also a way to see the information from the compiler below in the table, in the path record. Okay, questions so far? Well, as I said yesterday, the best to do is try these options in your application, and then we can explain you the specific case, what does mean a specific option when you try, for example, tracing in. If your application is very large, then, as I say, maybe it's not the best to do profiling for everything or tracing for everything. Maybe you want to be interested, so you can use HAPA to understand the automatic way, or you can be, more expert, I would say, and then you can set these options to go down in a specific function or a specific file. You can use APIs, for example, and you will understand what's going on there, okay? So the best suggestion is to use at the beginning just sampling. Then you say, okay, I'm spending 100% of the time in this function, okay? Can be. And then you will go that function, and you will do better and better, and then you will go to understand where you are spending time, and then how to optimize the code, and then again profiling and so on. This is interactive way. Okay, so how we can see now all these informations in a better way, we'll say, okay? Instead to go down tables and so on. So this application here, and this application can give you all the information. Of course, yesterday was the case where, of course, when you run path build, a path report, you are not producing given, for example, hardware counters. Then this application cannot show you hardware counters, because this application is fetching the information from an AP2 file that you are producing with path report, and then it's showing you the information, okay? It's just a way, instead to look at the path report tables, to show the information, okay? This is the GUI, so the meaning, in all cases, you have tabs where you have your application. Here you will see the executable of your application, okay? So you have different tabs if you are opening different files. Of course, on top of here, this file, then you can do open, and you can open your application, okay? Then there is a menu. Here you can see different views, okay? We'll go down some of these views, and the icons that you have here depends which tables are produced by path report, okay? As I mentioned before, hardware counters or tracing here is just produced if you are the path report table for that. Otherwise, here we will see less icons, okay? It was the case yesterday. Okay, then you click here, so which view you want to see, and you will have a tab here where you can see, for example, overview, which is the first one, okay? You will see the overview, and you will see the breakdown for a function sorted by call, so in this case, or sorted by time. Then you can click over this function, you will see other views. Here there is, so this is the timing of your application for start to begin, and you can move this to shrink in a given part of your application. Then here you can click here and switch in different views of this overview, okay? Here these are mentioned, for example, okay? So this is the same overview, just clicking here, you will see the breakdown, number of calls, so this is a bar chart, okay? Number of calls and time, and for the given function that you have here, basically, okay? And the 6 is the help button, so it's very useful to understand what's going on here, okay? All right, so this is the other view, as I said before, bar chart, where you can see what's going on for functions. And then if you click again on one of these functions, you will see the breakdown for program element, okay? Sorry, processing element, okay? And you can see, for example, in this case, if this is load balanced or not, okay? Here, the meaning of these lines are, this is the minimum, okay? So this function, particular function here, which is the MPI receive, was taking the minimum 37, sorry. I guess seconds, right? Yes, in seconds. And this is the maximum, and this is the average, okay? Of course, this is the number of calls, okay? So we can easily understand where we are spending time, because if it's a function which is called a lot of times, and then it's taking a small amount of time, then it will be very big, so you will see big bars here. So the best will go to functions which are called less, and they are taking a lot of time to do the optimization, okay? Not the other way around, okay? You can see here also the standard deviation, okay? So this is just when you, as I said before, from here, you click, and then you get the output, sorry, you click here. Then you get the output, and then you click in a function, and then you get this breakdown for each process element, okay? For a given function, okay? Then you can, this is another view, which is the profile view, and then you will see the dump for each function. This is interactive, so you can click on any of these of this part here, and you will see the different order, okay? And then you can click again, and you will see the source file, okay? So it's completely interactive, okay? Now, another view is the call graph view, okay? This guy here. And this is quite interesting because over here, you will see the time. So let's first understand what are the colors. So green means there are functions which are just calling other functions. So the main is just calling others, okay? There is no other call. Okay? So just green, like the main, okay? But there can be other functions which are just calling, okay? Main function, say. Then the other function here, for example, you have green containing all the colors, yellow, maximum time spent in a function, okay? So if you have large yellow, means that it's quite imbalanced, okay? Then you have purple, which is this part here, is average time spent in this function, and this light blue is the minimum spent in this function, okay? Then over here, you have the inclusive time, what I call inclusive time, so I prefer, and over here, you have exclusive time, okay? So in this case, we are taking this portion here. Inclusive is quite small, but then it's large because you are going over the time. And then in this case, for example, here, you are taking a lot of inclusive time as portion exclusive time. So this is a very small function, for example. In this way, you can see graphically, okay, where you are spending time, okay? Inclusive and exclusive, okay? You understand the difference? Inclusive, exclusive? I think so, okay? If you have questions, raise your hand, okay? And this is a graphic I say. This is, as I said before, the possibility to look at the source code and see for each file what's going on, okay? You can directly dump to your source file. So as I mentioned before, these are possibilities to produce these tables only if you're, of course, running path report with these tables, okay? Otherwise, the tool will not show you these informations. Of course, there is also a way to change, okay? So you can set different options. You will get different results. The full trace, when you set this variable, as I mentioned before, pay attention that you will generate a lot of information. Okay, so you can set all these other information to get other understanding. Same for the hardware reports. If you are setting the export hardware reports, the environment variable, then you will dump also the informations, and you will see a graph, a view that is showing you the average for each event. So it's very nice to understand instead of looking at the tables. Okay, you have a graphical way, and then maybe you want to show your presentation. You take a screenshot. There is a way to dump the screenshot, and of course you can easily showing your presentation, okay? There's a full description in this document here. By the way, this application allows you also to access to a file, so you can run this application in your machine, and then it is able to access to external machine, okay? It's not described here, but you can find more information here. So the GUI, if you are running a cluster which is maybe 1,000 miles from you, maybe you can decide to have the kilometers, whatever. You can decide to have the GUI in your environment, and then you can access an external server. Okay. All right. The other application is Reveal. Reveal is quite interesting because it's interactive in a way that you can have the code. Then it's suggesting you how to parallelize the code, OpenP, and then you can do this inclusion, and you can change the code. Okay. So it's interactive way to adding parallelization. Okay. So yesterday, in practical one, if you want, there is a sequential version, no OpenP, and a parallel version with OpenP of the main code. And one of the suggestions was try to apply OpenP parallelizations using this tool, using Reveal, okay? So this tool, you need to have a Cray compiler. For other tools, you can use any kind of compiler, right? Because at the end, you use path build, path report, it will just dump the information. It doesn't need to have the Cray compiler. In this tool, since you need to produce the program library, and to produce a program, you need the Cray compiler, so it's bound to the Cray compiler. Okay, so can you use the Intel compiler? Unless you have this command here, I don't think. Of course, there's no way. Okay, so you will dump the program. You use this flag to have the entire program dumping, and then you can open this directory, which is produced by this command here when you compile, and you will see the output. Okay. All right. So this is a description of what the tool does. As I said, showing before, it's a very interesting tool, so that you can use to understand your application, how to apply parallelization, and for example, scoping the variables and so on. I will show you some screenshot of what's going on, okay? So you open the tool, as I said before, for example, this is profile generation, compiling link, and then you put tracing, you open the tool, okay? Need to reveal, you can get more information from here, and then you see this application. So for each loop, for example, you can see which kind of optimization it's producing, okay? okay, here there's explanation. So these vectorizer are rolled by 4, okay? So you have this information here. Here you have the tracing information, so you can directly see where you are spending time, okay? You can have this information for the loops, and then you can have the feedback for the compiler. So you can select one line, and you can see what's going on in this line, okay? So in one single tool, you will have tracing information, optimize the information, so the path report output, and you will get also the information from the compiler, so the warnings from the compiler, okay? One single view, you can see all this information. And then you can interact, okay? So one way to do that, for example, is to click in one loop. You get, for example, information what's going on in this loop, okay? So this is a way to get information, okay? How this changes the loop, how it can be optimized, and so on. The other interesting thing, for example, when you have inline the functions, it will scope for you these inline the functions, okay? So when you do profiling, most of the time, if the function is inline, you will not see the function because it's aligning the function, okay? So it's changing your call with directly the code. And here you can do, you can see the real function, and this was the part which was inlined, okay? What they call pseudocode, okay? So you can see here, this function was inline, this function was inline, and then you click here, and you will see the real code, okay? So also this possibility for an inline function. Scoping, very easy. For example, you stay in a particular OpenP region, then you open this view here, just a right-click button, and you will see scoping function. Then you can see here scoping, and it will give you a list of variables. So it can tell you, okay, this variable is an array, okay? It can be resolved, so you need to set like shared or private, for example, in your OpenP region, or you can tell you if all the other variables which are correctly scoping. So you can see if there are errors and so on, okay? And then there is an insert, and this insert it will give you the output, and you can, the tool will add the output directly in the file, okay? So you are changing the file, adding this information, then you can store, you can save. Of course, you are taking a temporary copy of this file, but then you can decide to save. So you can add OpenP regions to your code, okay? The tool will tell you which the scoping on the variables and which pragmas or directives to use in this case, okay? This is the case, okay? So here, for example, is the example for this particular loops, which is not shown here. It will tell you which parallelization tips to use. So it's helping you to add parallelism, okay, basically in your application. So here is the case where it's dumping. So in the code, you can add this OpenP parallel do, default known, and then is adding which variable are shared and which variable are last private, okay? It's just producing for this output here. It can show you, and then you can insert in your code, okay? So you can interact with the tool, and you can change your code, and you can add more options or parallelism, okay? That's the end. The best is to try the tool. And as I said, the menu code is very easy, so you have a couple of OpenP regions that you can try in that case. Otherwise, you can take your application and see if it's working. Scoping is one of the problems, because most of the time you can have race conditions just because you are not taking correct clause for the variables. Reveal is work in progress. So if you have feedback, you are interested to understand if something maybe is not, we need to add or to change the package, okay? So we can provide feedback. It's a new tool, basically. Everybody's happy? Okay. Sure. No. The best for reveal is to open reveal, and this is the help menu here, and there is a lot of information there. You have help for everything, okay? You have wherever you click, then you can get help with the right-click button. For the other one, the best is to look in this document here. Otherwise, main pages, yes. Here, there is a description of all the screenshots. Okay, this is the last version for September 12. Inside here. Well, they have also in the main pages. It depends if you like PDF or everything is inside the main pages, of course. But path help, yes, indeed, path help is also that case interactive. So you do path help, it will show you a menu, and then you can have just setting numbers, and you will go down in different menus. I was mentioning before path help for going down, for the hardware counters, where you can get information for the hardware counters. Here. So you set path help, then you will get a menu where you set counters, and then inside you have another menu. Okay. Otherwise, you can just put this command, and you will get all the information in one shot, instead of three steps. So, of course, these tools are, as I said, evolving because we are supporting now Intel. So, hardware counters is still something in progress, I would say. But how many people are familiar with hardware counters? I'm curious to understand because, okay.